All right, so before we get into cloud computing, I want to understand what is your understanding about a data center. So what all you have into data center? So typically in a data center, in like a traditional data center, if we walk in, we might find there are several racks. In these racks, you will find multiple hardware servers are installed, and there would be a big switch with like multiple ports, and there could be a big storage like NAS box. This is how a traditional data center would look like. So in here, if you see, typically there would be multiple servers installed. So in a typical data center environment, for each and every role and application, we need a separate hardware server. And why we need that? That 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 I have to explain you about that structure of that server. So let's try to look into this one server. If you see here, typically when I buy a hardware server, right? So any electronic goods when you buy, it comes with some firmware installed on this, right? So if you walk into electronics showroom and you ask a laptop or a computer or anything without any operating system, you will find their firmware already installed, right? So typically what we do, we install an operating system over that, right? And this operating system, when we install, a kernel will be built, correct? And then whatever application I'll be installing here, they would be communicating to my hardware through this kernel, and they have to pass through this operating system, and that kernel would help me to talk to the hardware. Am I correct? So now you see, if I install multiple application or multiple role on one server, what it would end up with some conflict. There are chances that some of the role or the server might start taking too much of like exhaust my operating system, and then my server would slow down or might end up crashing, or my kernel can get corrupted. So to refrain this situation, or to save my to make my data center environment more stable, we end up trying to install one application or one role on one server, right? But this sounds to be a very expensive setup, because let's say I have 50 different roles, including high availability and other things that I want to configure in my environment. Then if I have 50 different roles, and you see I want a high availability too, so I would end up with a minimum 100 hardware servers. So that sounds like a big expense. Am I right? So to get rid of this situation, or to like you can say save some cost, we started moving to hypervisor. Now what is hypervisor and how it affects my environment? So in a hypervisor, what happened, again, if you buy a hardware, and then you will, it would obviously, it would be uh, with a firmware, right? Now I uh, I have this hypervisor is a small application which would let me to create multiple virtual machine on the same hardware. So on top of this firmware, I have a liberty to install that hypervisor directly, and this hypervisor would create a VM kernel for me. So how a OS kernel is different from the VM kernel? This VM kernel let multiple operating system to communicate with my hardware independently without depending on each other. So you see there is no in operating system in between, and they all can interact directly to my hardware. Now in this situation, I can have Linux here, I can have Windows here, I can have any like Red Hat here. So I can have multiple different type of operating system on the same hardware. Now you see I can install 10 different operating system on the same hardware, and they all are independent to each other. So I can install any role, any application on these servers independently. They are not going to interfere each other, so there's no chances of conflict, right? However, there is another version of hypervisor that you can install over the operating system. So basically there are two type of hypervisor. So I can say a hypervisor could be of two types. One is hosted, and another one could be bare metal. People also call it type 1 and type 2 hypervisor. So you see, in the bare metal is the one that we just spoke about, that you can install directly on the hardware. Right after the firmware, you can install this bare metal hypervisor, and you don't have to, it should not, it doesn't need to be hosted by any operating system. However, under hosted, we have to install it over an operating system. So right now you can go to Google and download, let's say, VMware Workstation. So your local operating system, if you're using Windows 10 and you downloaded VMware Workstation, so basically there is going to be like this. So this would be the firmware, and then comes your operating system, which could be Windows 10, right? On this Windows 10, I installed, let's say I installed VMware Workstation, right? Now, this VMware Workstation would let me create multiple different type of operating system here, right? And this all operating system would be communicating to my hardware through this operating system. So once again, I would be in the same situation where they all are communicating through my operating system. And for some reason, if my operating system get over exhausted or used, that means my server would be down and my environment would be unstable. So instead, for any production environment, we always prefer to go with bare metal hypervisor, right? So now let's have a look. So when I had this bare metal, this environment hypervisor, now again, let's have a look in my data center. So now this time I can have a server. In this server, I can create multiple virtual machines, right? And now these hypervisors are like improved, and they let me create virtual disk as well. And now I have virtual network as well. So all this virtual setup, virtual server or machine, and then this virtual network, and then I have virtual disk, right? Sounds like a quite scalable solution, right? So I have a quite scalable, and this is easy to manage, and I have a capability to serve multiple location over the globe, correct? So let's say I have a big server setup, like virtual setup. I can create as many as setup I want, and end of the day, these all servers would be basically a folder, correct? Because this disk would be virtual, and basically that would be a folder, right? So I can easily manage them, copy them, expand them, transport them, administrate them, and I have a highly scalable environment available. So now I'm capable of creating one data center, and from this data center, I would be able to serve various services over the internet or to different locations. So let's say I have a regional office in Singapore. I could have one in US, Europe, anywhere on the globe, right? And my this data center is a highly scalable virtual data center, and I'm able to serve them or provide them services over the internet to any part of the globe, right? So this sounds like a highly scalable solution, and this is what we are going to call it as a cloud, correct? So basically what cloud is, so if we think about what is cloud, right? So in this session, we are going to study about what is cloud, why cloud, what are the models of cloud, and what different type of services we can categorize into. So what is cloud computing? So cloud computing is basically delivery of computing services. Like it could be server, it could be storage. So cloud computing is basically a way of delivering computing services. It could be server, storage, networking, some ready-made solution, and they offer faster, flexible resources, and they are like more economical, cost effective, and and they reduce our operational cost, and we can scale up as we need for our business requirement. Okay, so what are the top benefit of cloud computing? First, as I said, cost, correct? So I don't have every time I need to configure a different role or application. I don't have to rush to buy a new hardware. So I can keep using the same hardware. I can keep adding more hardware to the same structure, and I can build my entire infrastructure. It has more speed, and then I can scale it up globally. I don't have to worry which part of the of the globe I'm going to expand my business, and if I can do the setup there. So I can provide services from one cloud data center to any location on the globe, right? And then I can maintaining a data center is really a huge task. You have to take care of the hardware, you have to take care of the operating system, then the application, and then you have to look at the security, then you update. As you know, like all the server services keep on upgrading time to time, so we have to keep updating our hardware and the software patching. All this management course we have to take care of, but instead of the cloud we don't have to look all this part, and then we can use that time and efforts and our time. We can really use this time and efforts to achieve our business goals, correct? And then performance wise they are really high, and then reliability more, it is more reliable and more secure. So let's talk about like what kind of, depending on this deployment model, we can categorize this cloud concept into three different parts. So as I just said, in that previous example we spoke about, I can have a data center. I can set up a data center, and this data center I can use to serve into any part of the globe, right? It could be any location, and I would be able to serve it from here. So but this data center is dedicated to one company, right? So only, let's say if I am a company like anyone like IBM or anything, and I set up a data center, and only my resources, my company, my business can use this resources, and I can provide it over the globe, but those all resources should belong to my company. So basically it's a private property that can be used only by my company resources, right? So we are going to call it what? A private cloud, correct? So it's a private property. It would be serving only to my private resources, right? So this a setup that is dedicated to single business or organization, right? And it is generally on a like an on-site data center, and it works on a private network normally, right? So we can call it a private cloud, correct? But you imagine, there is some company like Microsoft or AWS, they build this data center and they said anyone, whoever wants to subscribe these services, they can come over, subscribe our services. We are ready to give you, all you have to do is to pay for what you use, right? So they have this data center, and anyone, it could be a big company like Deutsche Bank or like anyone, and there could be a small new startup, right? Anyone can walk in there, subscribe the service, and they can get access to their web portal, and they can create their resources there, use it, and pay whatever they use for. So more like I would say it's like your electricity bill. You use the service and you pay for the units that you have used, right? Or your gas bill. The same thing is happening here with the public cloud. So anyone and everyone is invited, they can use the services. So I am a new setup, I just want two servers here, and then there could be some big e-commerce company, and they want like a bigger chunk, like they want a bigger servers and bigger setup. So anyone is invited, anyone can use the service and pay accordingly. So this is what setup is, a public cloud, correct? Now there could be a third scenario. Third scenario means there is a possibility that my company already have a setup that is a private cloud, right? And then I decided to use some of the services from the public cloud too, right? So now you see most of the companies are using O365 as the mailing solution. I hope you have heard about it, right? So O365 is basically a like a set of softwares like Mailbox and Microsoft Office, and there are so many other software that is bundled together and that is being given to the company. They can use it. Subscribe is a ready-made package, right? So now imagine I have my database, I have my storage, I have my all setup in my private data center. However, my mailing services, I'm using O365 mailbox. So I have a private setup and I am also using the public setup, public cloud, right? So I have a combination of public cloud and the private cloud both. So basically I have a hybrid setup, right? There could be a scenario that like I am heavily using the public cloud and then I decided to set up a few services in my private data center. So in that case also it would be called a hybrid setup. So so basically it should be a combination of public and private cloud, correct? So now we know what is cloud, right? We know what is cloud services, and on base of deployment, we can divide into three categories: public cloud, private cloud, and hybrid cloud. Now let's look at the services. So there are so many services are available on the cloud. So how to divide them or categorize them? Right, because there are so many services, so basically we try to divide or categorize them as per what services we are going to use, correct? So imagine if I am using or trying to do my personal data center setup, so I would be looking at the hardware part, I would be looking at the network, I would be looking at the storage, then I would set up an operating system, then I would deploy some tools or the application, right? Then I would host some application. So while I am convinced that I want to move to cloud, now I have to decide what all services I'm going to subscribe from them. So am I going to subscribe only infrastructure, or I want a ready-made platform, or I'm going to subscribe some software. So for example, if I decide that I need two virtual machines there to set up my data center or set up my application or database. So I took two for example, I took one Linux machine and I install Apache server on that. So what I'm subscribing there is the server, right? And the network or the firewall setup and maybe a storage. So this is purely an infrastructure that I'm subscribing. Now I would and my team would decide how to configure that server and how I'm going to use it. So what we are doing here is I'm taking the infrastructure part. So we'll call it infrastructure as a service, right? Now let's say I have a team of developer and we really don't know how to configure a server, but I really need a database, correct? So maybe we are developing an application which in background need a Oracle database or maybe a SQL database or something like that. So instead of taking a server, installing Oracle or SQL services on that, we decided that we are going to take a SQL database, right? And we just subscribed the SQL database there and we started using that database with my application. Now, this doesn't mean that there's no server or storage or network working with that. It just means that I'm not the one who is going to configure that, or I do not have access to configure that server, storage, or the network. I would be using only that database that I have subscribed, correct? So this is what basically I'm taking is as a platform. So I'm taking a platform as a service. So we are going to call it PaaS services, right? Now, beyond this, there could be a scenario that we just spoke about O365, right? So O365 is a set of software. So typically, if you install a mail server, there you have to configure multiple servers, configure different roles. You have to install maybe Exchange, MS Exchange on that, and do all this setup. So that would have been an IaaS setup, like infrastructure as a service. Now, when I'm taking O365 and I'm subscribing simply a mailbox there, so I don't know, there is still a server in the background. There would still be some software operating system or database in the background, but I would not have access on that. I would have access only for the mailbox that I asked for. So I asked like I want 5 mailboxes, right? Maybe Shruti at hotmail.com, Sinha at hotmail.com, Aditi at hotmail.com. So I asked three mailboxes, right? So I got access on these three mailboxes only. So I have, right, what I'm using here is basically software as a service. Correct? So we can categorize these services in three main category: infrastructure as a service, platform as a service, and software as a service. A new type of service, a new category is introduced lately is server function as a service or serverless um, computing. So serverless computing is basically subscribing a few service functions from that server. Now, imagine, as I said, I am a developer and I'm trying to develop an application, correct? Now, my application need to send a email notification every time it is successful, correct? So, in case I want to do this, I would have to set up a complete mailing system and then do set up a notification there and connect it to my application. However, serverless computing allow me to just subscribe one function, that is sending notification, right? So that part is also available now, and we call it serverless computing. So this is what we just discussed: infrastructure as a service, platform as a service, and software as a service. And the next one is serverless computing. So the next one is serverless computing. So it overlaps somewhere between the platform as a service and function as a service. So in this, as I said, we can subscribe certain functions. We don't really have to subscribe a platform, or we have to configure a platform, or we have to configure a server or something. We can simply go ahead and subscribe a function, and that can be event driven. For example, like I said, like I'm building an application, and that has to trigger a notification whenever my function is successful. Or maybe I'm building an e-commerce platform, and every time my customer purchase, do some shopping or confirm their payment, they should be getting a confirmation email saying like your order is placed and it would be delivered by so and so timing. So this is something that function has to be happen when some event is completed, right? So it has to be triggered by some event. So this is what we call it function as a service or serverless computing. So now we will be moving on the to see how many data center and why we are going to learn Azure or AWS, why we should choose one.